This is chapter Pure Chem, chapter 22, Science Chem or Combined Chem, chapter 19, Normal Acad, Chemistry, chapter 15, Alkanes. Okay, so the first part is the lesson objective is describe the alkane homologous series, name the 4 alkanes, describe the characteristics of the alkane homologous series, draw the structures, as well as define isomerism and identify isomer. Now the last lesson objective is only applicable to pure chemistry. So from the previous lesson, we look at what is homologous series. Okay, so homologous series is basically is a families of organic compound. It's just like human, you have different families of human. They are the races or the ethnic groups. Okay, so the first homologous series that the first family of organic compound that we look at now is called alkane. All right. So what is alkane? So alkane is a homologous series of hydrocarbon, that means only hydrogen and carbon, with carbon-carbon single covalent bond. So the carbon and the carbon are bonded by a single covalent bond. So an example would be this one. Okay, so this is actually an alkane because all the carbon atoms are bonded by one covalent bonds, which means that they share one pair of electrons. Okay, so another example would be methane. Methane, there is only one carbon atom. Okay, the methane. So if you look at the carbon atom, all the carbon atoms must share 4 pairs of electron because carbon, the electronic configuration is 2,4. Okay, it is short of 4 electrons. Therefore, it must share 4 pairs of electrons. Okay, carbon-carbon single covalent bond, that is alkane. And alkane is a saturated hydrocarbon. Now, what is the meaning of the word saturated? Saturated means that you cannot add more things to it. For example, my brain is saturated, meaning that I cannot absorb any more new information. Now, likewise, for alkane, it means that you cannot add any other atoms to it. Now, what do you mean by that? So, for example, if I break this single bond here, okay, if I add this single bond, okay, I will add another substance to it. Okay, so for example, I add a chlorine to it. So this is one atom, this is also one atom. I cannot add any more atoms to it by breaking the covalent bond. Now this is in contrast with double covalent bond. Now when you have carbon-carbon double covalent bond, this is not saturated. This is actually unsaturated. Now what do you mean by that? If I break this carbon-carbon double bond, I can actually add some more things to it. Okay, so each carbon must share 4 pairs of electron, right? So I can actually add some more. I can add hydrogen, I can add chlorine. So carbon-carbon double bond. This is carbon-carbon double bond. It is unsaturated. And carbon-carbon single bond, it is saturated. So whenever you have carbon-carbon single bond, it is called saturated hydrocarbons, meaning that you cannot add other atoms to it. Okay, saturated, unsaturated. Okay, alkane, we look at the general formula. The general formula is CnH2n+1. Now this general formula is very, very important if we want to come up with the molecular formula of some other alkane compound. Okay, so for example, propane. So propane, what would be the chemical formula for propane? So prop means 3 carbon atom. So the N basically is 3. So if C3, H 2 times 3, that will be 6. 6 plus 2, that will be 8. That's why the molecular formula for propane is C3H8. Okay, so this general formula is very useful for us to get the molecular formula of all other alkanes. Okay, likewise for butane. So from the name butane, you know that it is the prefix is but. But means 4 carbon atoms, so it's C4H10. Alright, now let's look at propane is C3H8. The structural formula would be written as this. So take note that each carbon atom must share 4 pairs of electrons, must have 4 lines, or must have 4 bonds around it. And each hydrogen must have only 1 bond around it, meaning that it shares 1 pair of electrons. Now this one would be the condensed structural formula. Condensed structural formula basically means that I collapse all these hydrogen atom. I remove all the lines. So this part here, okay, this part here would be CH3. That's why CH3. And then the middle section CH2, CH2. And then this part CH3, CH3. So condensed structural formula is obtained by collapsing the structural formula. Okay, likewise for butane, okay, the structural formula is like this. Condensed structural formula, basically you condense everything, so becomes CH3, CH2, CH2, CH3. Now, propane and butane, you have 3 carbon atoms, you have 4 carbon atoms. The difference is how much? The difference is you have 4 carbon atoms here, 4 carbon atoms, 4 carbon atoms here, 3 carbon atoms here. So the difference is 1 carbon atom. And then 10 hydrogen atoms, 8 hydrogen atoms. So the difference is 2 hydrogen atoms. So the difference is CH2. Okay, so successive alkane molecules, the difference is CH2. So likewise for, let's say, ethane, okay, 2 carbon atoms, that will be ethane. Ethane and propane, the difference is CH2. Now is the characteristics of alkane. Now alkane doesn't have any functional group, okay, no functional group. Have similar chemical properties. All of them, they have chemical properties, and show gradual change in physical properties. This one we'll look at it in the 3rd page. Have the same general formula, CnH2n plus 2, and each member differs by the next by CH2 unit. So this is basically what I meant by here. Okay, each member differ from the next by a CH2 unit. Alright, so you have methane, ethane, propane, butane over here. Okay, so far we have already looked at the alkane homologous series. Okay, describe the alkane homologous series, the general formula, the difference between each member, as well as the functional group, etc. Okay, name the first 4 alkanes. So you have methane, ethane, propane, butane. And then describe the characteristics of the alkane homologous series. So these are the characteristics. And then draw the structures of the first 4 alkanes. So you should have no problem of drawing the structures of, let's say, ethane and methane. So methane is here, 2 carbon atoms, that will be ethane. Ethane should be quite similar to this. And then the last part, define isomerism and identify isomers. So as I mentioned just now, this learning objective is only applicable for pure chemistry. Combined chem and normal acad chemistry, you don't need to, this isomerism is not in your syllabus. Okay, this is isomerism. What do you mean by isomerism? So what are isomers? Isomers are basically compounds that have the same molecular formula but different structural formula. Okay, so for example, you have this butane C4H10. So this is the structural formula for butane. Now this butane, I can also draw it like this. Okay, if you count the number of carbon atoms and the number of hydrogen atoms, it would be the same as C4H10. So this is another way of drawing butane. So if you have same molecular formula but structural formula are different, which means that these two are isomers. Okay, these two are isomers. How about these two? These two structural formula. So first thing is you need to check the molecular formula. Are they the same first? Molecular formula are the same. You can count the number of carbon atoms and the hydrogen atoms. How about structurally? Structurally, are they the same? Actually, these two structures, they are the same. Why? Because this one, you can flip it. When this, you flip it, the branch would be at the top. Okay? So these two are same structural formula, same molecular formula, which means that these two, they are not isomers. Okay? These two are. Alright? Now let's look at isomerism, the properties. So isomers have different chemical properties, different physical properties. Everything is different. Chemical plus physical properties are different. They are basically just different chemical compounds, even though molecular formula are the same. Okay, they are different chemical compounds. Now, how do I get the isomers? How to get the isomers is by, it has several steps, but the most important step is by removing the hydrogen atom from the alkane. So for example, in this case, I remove the hydrogen atom. So the first step is remove this hydrogen atom. Then after that, I join this hydrogen atom, I join with this CH2. So this hydrogen atom, I come here. So this one I break. This one I break. So this CH3, I shift it to here. So it will become like that. So isomerism starts off with removing the hydrogen atoms first. Okay. So these two, this is actually, so this butane is a straight chain alkane. Straight chain. That means all the carbon atoms are in one straight line. So this is straight chain alkane. This is called branch chain alkane. Okay, branch chain, meaning that you have a straight chain here, 3 carbon atoms, and then after that there is a branching here. So this is a branched chain alkane. This is a straight chain alkane. Okay, these two, they are isomers of each other. Why? Because molecular formula same, structural formula, they are different. These two, the structural formula are the same because you just need to flip it. They are the same. You don't need to remove any hydrogen atoms. Okay, you just flip it, they are the same. So that means structural formula, they are the same. Same structural formula. This one, these two, regardless of how you flip, this thing, this structure will never be the same as this structure. So if that's the case, no matter how you flip, the structure are different. If that's the case, these two have different structural formula. Alright, now the naming part, we will look at it on page 4, I think. Okay, on page 4, why is it called methyl propane? We'll look at it on page 4. Okay, so that would take care of isomerism and identify the isomers. So remember, identify the isomers, make sure molecular formula must be the same, structural formula must be different. Okay, now we look at the second learning objective, which is explain why alkanes show a gradation in their physical properties down the homologous series, and also describe the chemical properties of alkanes. So we need now we need to look at the physical properties and the chemical properties of alkane. So alkane, all of them are colorless and odorless, alright? And then they are soluble in water, insoluble in water, soluble in organic solvent. So this is basically the properties of covalent of a simple molecule. Okay, simple molecule like carbon dioxide. Okay, it is insoluble in water, soluble in organic solvent. And physical properties, flammables. Now let's look at the trends of their physical properties. So physical properties, how do physical properties change on going down the alkane homologous series? So as you go down, you go from methane, ethane, propane, butane, pentane. So as you go down, what happened to their physical properties? Let's look at the melting and the boiling point. So as you going down the alkane homologous series, molecular size increases. correct? You can see the molecule CH4, very small molecule, and then C2H6 bigger, C3H8 even bigger, all the way big. So as you go down the group, go down the homologous series, molecular size increases. When the molecular size increases, intermolecular forces will increase, just like for the planet. As the planet gets bigger, the gravitational force will become stronger. Same concept. Okay, molecular size increases, intermolecular forces increases. So when intermolecular forces increases, large amount of energy is needed to overcome the forces to separate them. So melting and boiling point increases. All right. Now, likewise for viscosity. What's the meaning of viscosity? For example, water and paint. Which one is more viscous? Paint is more viscous. So a liquid that is more viscous would flow slower, because paint will flow slower than water. All right. Okay, so that is viscosity. So molecular size increases, intermolecular forces increases. Same thing with viscosity also increases. So the liquid will find it harder and harder to flow, or flow slower and slower. Viscosity. Now, how about flammability? As molecular size increases, the percentage of carbon will increase. How do you find percentage of carbon? Let's say in methane, ethane, propane. Let's say CH4. How do you find the percentage of carbon? So you find the percentage of carbon by finding the AR for carbon, which is 12, over the MR of the entire thing, which is 12 plus 4, 16. So 75% percentage of carbon. How about for ethane, percentage of carbon? There are 2 carbon atoms here, so there will be 12 times 2. Will give you 24, divided by the MR for the entire thing, which is 24 plus 6, which is 30. Okay, 80%. So as you go down the homologous series, the percentage of carbon increases. When the percentage of carbon increases, it means the flammability decreases. More and more carbon, a high percentage of carbon, means that harder and harder for it to catch fire, the flammability decreases. Okay, and more and more carbon also means that the flame become more and more sooty. That means more and more black smoke. Okay, so this part is very important. Percentage of carbon in alkane affects its flammability as well as how sooty the flame is. More carbon means less flammable, more sooty. More sooty means more black smoke. The black smoke, the black particles inside the black smoke is actually carbon. So when there is a high percentage of carbon, it means that the flame become more sooty. All right. So this part is very important. This part, and this is the evidence. Okay, now is the chemical properties of alkane. Now, alkane generally is unreactive. Okay, it undergoes several chemical reactions. The first one is combustion. Combustion, of course, you have complete combustion and incomplete combustion. Complete combustion, it will give carbon dioxide and water vapor. Okay, this is the water vapor. That's why it's gas here. And for incomplete combustion, you will get soot, or this is soot. You get carbon monoxide. You get water vapor as well. Okay, complete, incomplete. Excess supply of oxygen and limited supply of oxygen. All right, and of course, both reactions are exothermic, meaning that they give out a lot of heat to the surrounding. So the first chemical property of alkane is combustion. The second chemical property is substitution reaction. Now, this substitution reaction is very important. All homologous series for the subsequent chapters, alkane, alkene, alcohol, they all undergo combustion. Okay, so this reaction is common for all the homologous series, but not for substitution reaction. When you see substitution reaction, it is exclusive to alkane. Now, what is substitution reaction? Substitution reaction basically means the alkane reacts with bromine or chlorine in the presence of UV light. Okay, so what happened is the hydrogen atom of the alkane is substituted by the bromine or the chlorine one by one. one by one of the hydrogen atom is being substituted by the chlorine or the bromine in the presence of UV light. So for example, this one is methane. Okay, I react with chlorine in the presence of UV light. So what I get after that is one hydrogen atom is being substituted by one chlorine atom. So you get something like this. So this is called chloro methane. This is methane, but one of the hydrogen atom is substituted by chlorine atom. So it becomes chloro, not chlorine, chloro. And then after that, after a while, two of the hydrogen atoms would be substituted by the chlorine atom. So you get dichloromethane, 2 chlorine, and then trichloro. And finally, all the hydrogen atoms have been substituted by the chlorine atoms. You get tetrachloromethane. Tetra means 4 chlorine methane. A methane atom, a methane molecule with 4 chlorine atoms, no hydrogen atoms. Okay, so this is substitution reaction. And of course, the third reaction that alkane undergo is cracking. So cracking, alkanes with long carbon chain is broken into smaller molecules. This cracking reaction, we'll look into it in more detail under alkene in the next chapter. Alright, so 3 chemical properties or 3 reactions that alkane can undergo: combustion, substitution, and cracking. Very important is substitution reaction. Alright, so that would take care of the lesson objectives. Describe the chemical properties of alkanes, and of course before that is show a gradation in their physical properties. That means show the gradual change in the physical properties down the homologous series. So basically is these 3 parts here. Okay, that's all for alkanes. Thank you for watching.